welcome to video number 5 in our explainer series where we're looking at the rules of exponents and why they work the way they do. Today we're looking at negative exponents. So remember when we did our second video looking at the division rule, right? We looked at a scenario where we had more a's at the top of the fraction than at the bottom. And so all the a's at the bottom got cancelled out and we were then left with a to the power of some positive integer. This kind of hints to us what negative exponents mean. Let's look at an example. So suppose we have something like this, a to the 3 divided by a to the 4. Using the same ideas as from the second video, we could write this as a times a times a divided by a times a times a times a. Right, so we can see that this a and this a pair up, this a and this a pair up, this a and this a pair up, and then we have an extra little a at the bottom, right? So we end up with a over a times a over a times a over a times 1 over a, right? If we put this back into one fraction, we'll end up with a to the 3 at the top and a to the 4 at the bottom, okay? Then what happens? This ends up becoming a 1. A over a is 1. A over a is 1. And so effectively what's left is 1 over a, right? So a to the 3 divided by a to the 4 ends up being 1 over a. But using our division rule, a to the 3 over 4 is the same as a to the 3 minus 4, which gives us a to the negative 1. So we see a hint of that relationship over here. Let's look at another approach. Oops. Okay, so same-ish issue. Right, suppose I have a times something is equal to 1, right? So what could this thing be? From our knowledge of fractions and reciprocals, we know that this number over here, or this expression, would be 1 over a. If you have 2 and you times it with a half, you end up with 1. Or if you have 5 and you times it by a fifth, you end up with 1. So same logic applies over here, right? But let's use our knowledge of the first rule of exponents, the law that if you times two powers that have the same base, you can just add their exponents. And let's use that to think about, okay, we know that a is the same as a to the power of 1. What can I add to this 1 so that I end up with 1 over here, bearing in mind that 1 is the same as a to the 0. What I would need to add is a negative 1, right? And what does that mean? That tells me, okay, this is the same as a to the 1 times a to the negative 1 will give me a to the 0. And a to the 1 is the same as this, and a to the 0 is the same as this. So that suggests to us that a to the minus 1 must be the same as that. So that's where this relationship comes from, right? And then it's not very hard to see from there that in general a to the negative m is the same as 1 over a to the m, right? To see this, one of the ways we can look at it is using the idea from our third video, the idea that if you have a to the b raised to the c, it's the same as a to the bc, right? So I can then express a to the negative m as a to the m times negative 1, which is the same as a to the m raised to the power of negative 1. And from the previous slide, we've seen that a to the negative 1 is equal to 1 over a. So this guy to the negative 1 must be the same as 1 over a to the m. And so we have that relationship as well.